yo, they got me handcuffed. I'm down in central booking. Things are fucked up the way my future's looking. But I'm too fly.
Hello, and welcome to the practice problems video for related rates. Alright, for this example, let's read the problem first. So a spherical snowball is being made so that its volume is increasing at the rate of 8 feet cubed per minute. Find the rate of increase of the radius when the snowball is 4 feet in diameter. Okay, so what we're going to do, so upon reading the question we get that, okay, there's a snowball being made and it's in the shape of a sphere. So let's sketch that out. So the first thing is to draw a picture, right? So if we sketch out a sphere, it looks like a circle, and then, but it's three-dimensional, right? So something like that, okay? And we have our radius here. Okay, so we have this snowball, and it's actually growing, so it's becoming bigger and more massive at a rate of 8 feet cubed per minute. So what is that? So identify what you're given in the problem, first of all. So dv dt, that's going to be the rate of change of the volume. Okay, so this is volume is increasing at the rate of, so that tells us the rate of change of the volume is equal to 8 feet cubed per minute. Okay, what are we supposed to find? Find the rate of increase of the radius. So what we're going to find is how is our radius changing with respect to time. Okay, what else are we given in the problem is when the snowball is 4 feet in diameter. So we're given that d is equal to 4 feet, so that means our radius, our r, is equal to 2 feet. Okay? So now how do we even work with this? So first of all, what I would suggest is probably, let's write down a formula relating the radius along with the volume. So volume of a sphere is actually given by v is equal to 4 over 3 pi times r to the third. Okay? And now what I would actually suggest is, before you plug in anything and find any values, is let's differentiate, let's do our implicit differentiation with respect to time, and then we'll see what we need after that. So if we ddt both sides, so we're going to ddt both sides, and we get on the left side we have dv dt, okay, is equal to 4 pi over 3 is just a constant, and then if we ddt the right side we get 3r squared times dr dt, okay, so then the right side actually simplifies to 4 pi r squared times dr dt. Okay, so now we have this relation that dv dt is equal to 4 pi r squared dr dt. Alright, so now at this point, let's see what we have. So we know our dv dt, so that one's good. We know our r, which is 2 feet at this time, so I'll box what we know. So 2 feet, we don't know dr dt, and we do know dv dt. And so we have this one unknown left. Okay, so I'll continue writing this on the next slide. So the equation that we obtained by implicitly deriving with respect to time is dv dt is equal to 4 pi r squared times dr dt. Okay, this is the thing that we're trying to solve for. So this is left unknown. Okay, let's see, and then like I said, dv dt, we do know this, okay, and we do know the radius at a certain time. The radius that we're looking at is at 2 feet. Okay, so let's plug in the values and solve for dr dt. So dv dt was given as 8 feet cubed per minute, okay? And then on the right side we have a 4 pi, and then our r is 2 feet, so we're going to plug that in there. And then we have our dr dt on the right side. Okay, so let's simplify. So we have an 8 feet cubed per minute, okay, is equal to, so this will turn into 4 pi times 2 squared, so that would be 4 pi times 4, so 16 pi feet squared, and then we have our dr dt there alone. And so if we solve, we're going to get that dr dt is equal to 8 feet cubed per minute. Okay, and then that's divided by a 16 pi feet squared. Okay, and then so the feet squareds cancel out, so we just have 8 over 16 pi feet per minute. So that's going to turn out to be a 1 over 2 pi and then feet per minute. Okay? Alright, so this is the rate of increase of our radius.
I know that I'm a role model, but yo, this rap life is real life. Sometimes it's full throttle. Right now I gotta think about me. Fuck the industry, you get no love.